You know all about the EWI Assist Program. Deadline is day after tomorrow, Friday. If you're going to apply for that scholarship, get it done soon. And then other scholarships, they have listings in the Financial Services Office. All right, before we get started on today's differential equations, let me go over just a little bit of the background. Now, I was going to return everything I could to you, but I really need everything turned in also. Okay, now, research papers I can't return until, because they periodically ask for samples of student writing. Oh, and look at this. Here comes research papers, test, everything. Fantastic. I think, and I just lost my place. Okay. So, there's your test one. Have I gotten any test twos in? I think that was the first one, wasn't it? Not really. I think I got one in. But it's a person who's not here. Let's see, there's test 2. Oh yeah, but I don't have finished grading. I got it marked but not graded. Okay. Okay, now let's go over end of the term situation here. First, have you done the student course evaluations? Yes? Yes? Not yet. Okay, that's all right. You have till the end of the term, but please don't forget about it. Please do the student course evaluation. And those listening at home, please do the student course evaluations. Okay, check your emails. It has directions of how to get there. All right, that done. I'll be giving you, I've already passed out what test I had, not many, and I need the rest of them coming in soon, very soon. I think this class, there's 2 distance folks who haven't turned anything unless they've emailed it to me. Matt just turned his in, so I think we're okay there. On the first test, 1 distance person, and Matt just turned his in, I think. No, first test, I just gave you his back. 1 hasn't, and 2 haven't turned them in. And then second test, I just got the first 2 in. Okay, so far. So please get those to me. Today, tomorrow, Friday. Now, let's just talk about today. Once this class is over, Nigel's going to show up. I mean, no, he showed up before. So Nigel is here. Okay. Oh yeah, Nigel turned in some stuff earlier today. Okay, yeah, I forgot. Okay. Class runs as usual today, and as soon as this class is over with at 3:15, I've got office hours until 5:15. Probably a little later. I've got an awful lot of papers to grade, so I won't get them all graded tonight, but I'll grade as much as I can for as long as I can until I give out. So I'll probably be here past 5:15. Hopefully I won't give out before then. Okay. Then tomorrow, classes are normal, okay? Office hours, 10:45 till 1. No, 1:15, okay? But I'm guessing, and this is just a guess, we may finish that second class a little on the early side, okay? And if we do, I may have some more office hours up until 6 o'clock. I can't promise that, but just the way things have been going, I think we'll probably finish the chapter, and then I'll give them the lab, and they can work on the lab, and I'll probably give them over the weekend to work on it as well. And so more than likely, I'll have some time in the office, you know, maybe 5 o'clock or something like that until 6. Okay? Friday, I'm on the Birmingham campus. Normally, 7:45 until 1. However, tomorrow, not. Okay? 7:45, I'll still be there. But I'm going to have to leave around 12-ish or so. Maybe 12:15, maybe a little before 12. My wife has professional meetings in Amsterdam, okay? And she's flying out tomorrow, and I've got to get her to the airport because we don't want to leave the car at the airport that long paying all that much money. And since I'll just leave campus a little early, I'll get permission. I think it'll be an issue. I've been here late every night so far, and I'll probably be here late tonight too. So I'll be out of here probably off the Birmingham campus around noonish tomorrow, not 1. So don't come by after noon. Now, that's this week. Next week, it's kind of final exams week, but one class, I've still got classes, okay? I got a mini-term course. They still have classes next week. So, my Monday, I have no in-class finals. All 4 classes have take-home finals, so I probably won't be up here in the classroom unless a student comes by to make up a test or something, any student from any of my classes. If that's the case, I'll probably take him to the nearest empty classroom from my office, which I usually start looking at 263, 256, 261, 254, 259, 257, or here. Somewhere between 265 and 265, I'll try to find an empty classroom closer to my office so I can go back and forth to my office with fewer steps and maybe even catch the phone if it starts ringing before it goes to voicemail if I hear it. So, that's going to be Monday and Wednesday. Same thing. 7:45 to 5:15, both days. Tuesday, I have a final exam here in this room, 8 to 10 approximately, okay? So, and if any of them need to stay late, I can stay late, no sweat. So I'll be here at least 8 to 10-ish or so, and then after that, I'll be down in my office until 1:15, at which time we have class up here. And that class, like I was saying, or I wasn't saying, but my guess is if we're finishing one chapter, then we'll do the lab in that chapter, and then we'll have a test in that chapter, okay? And the odds are we may be finished a little early then too, okay? Because this is the really end of the class. So I'm guessing 4 to 5-ish I'll be through with that class. It may go later, but 4 to 5-ish I'll be that one, okay? Wednesday I already talked about, mostly in the office unless people are coming in to do makeups. And then Thursday, I have no finals in the morning, but I do have that one final in the afternoon. But here's what I've done with that class. This is a mini-term class. At least half of the class are automotive students. Now those automotive students, some of them are from, I know at least one's from Mississippi, I think at least one's from Florida, and they're from all over the state, you know, so a lot of them are driving a long way. And my guess and understanding is that's probably their last final exam. And most of them are graduating too. So they're wanting to get out as soon as possible. So rather than making them stay until Thursday afternoon to take their final, I'm giving them the option if they want to take it earlier, anytime during finals week, after we finish the material on Tuesday, they can. So that's why I may be administering exams at various classrooms, because they have that option. And then to my other students, if they don't finish a test next Tuesday morning, they can come in and finish it. Or if they miss the test and come in making it up. So that's why I may be out of the office in the classroom giving makeup tests. So if any of that happens, I may have a very small crowd here Thursday afternoon at 1 o'clock or 1:15, whatever time they come by. I'm guessing some of the career tech folks who may have other finals going on, they may want to wait till that last day and take the final. I don't know. I'll find out next week. So 1 to 1:15 is check for me here. If I'm not here, check my office or anywhere in between. Okay? So that's the Thursday class. I mean, that's my last day of finals, Thursday. Friday is the last formal day of finals. I don't have any finals on Friday, but I'll be in my office on the Birmingham campus, 7:45 until 1. I don't think I have any reason to leave early that day. Karen's flying back that afternoon, but it's going to be later in the afternoon, so I can get on plenty of time to pick her up. Okay. Now, once that's done, that's the end of the term for y'all. Okay, y'all are probably going to be gone by then anyway. But the following week, we have duty days all week long. Okay. Now, what that means is I'll be grading anything I haven't finished grading by then. I've got Monday and Tuesday to grade it, and I think until noon on Wednesday. But I think noon Wednesday is when all grades have to be in. So anything that I haven't received in time to grade and get in is going to be an incomplete. So even if you turn in something Friday afternoon, slide it under my door when I come in that Monday, I'll be able to grade it and get it in the system. Okay. So you have all next week to turn in your stuff. Okay. Remember, your paper is going to be losing points after today. The research paper is due today, but then other things, get it into me as soon as you can, but anytime through Friday will be fine. Okay. Have I hit all the things? Okay. That following week, are any of you graduating? Okay. Here's the story. I probably will miss your graduation because I have, we have a family graduation at LSU, and it's going to be on Friday. And we'll be driving back Saturday, and there's no way we're going to get back here in time for the graduation ceremony. So sorry I'll miss it, but I'll be taking personal leave. I don't know if it's going to be all day Thursday or not, but it'll definitely be all day Friday. You got it, okay. Just a bunch of claws, okay. And actually, next weekend, the weekend at the end of finals week here, I have a niece graduating at Auburn. So those Tigers, okay. So Tigers, Cougars, Tigers, okay, yeah. So, but I won't miss any time for that because Karen will fly back sometime late Friday afternoon. We drive right down to Montgomery, spend the night, then head to Auburn, and then come back. So I won't miss any time here. I'll be going to a graduation, but it won't cost. But the LSU graduation is definitely going to cost. All right, I think we're up to date. Any questions on end of the term features? Okay. Where we left off last time was Chapter 4, Section 4.4. Chapter 4 is higher order differential equations. 4.4 is undetermined coefficients, the superposition approach. And we're looking at, on page 144, case 2. Now, case 1, yp is a linear combination of all linearly independent functions that are generated by repeated differentiation of g of x. Case 2, the function in the assumed particular solution is also a solution of the associated homogeneous differential equation. This is very similar to what happened in example 4, the glitch in the system. Okay? So here's the example. Example 7, case 2, particular solution. Find a particular solution of, let me get my pen back to black, page 144. Find a particular solution of y double prime minus 2y prime plus y is equal to e to the x. Okay? Now, all it said is find a particular solution, but guess what? To know whether that particular solution is going to work or not, we really need to know what the complementary solution is. So what is it? Where would we begin? The what? The auxiliary equation, which would be m squared minus 2m plus 1 equals 0. Okay, we'll treat it as a homogeneous part. Okay, and what does this give us? Say again? Been a long time, huh? -1 and -1. Double root at 1. So m equal 1 is our thing here. But since it's a double root, what does that make our characteristic solution? Y is equal to C1 e to the x. But since it's a double root, we have to have another for the C2. What would that be? X e to the x. And guess what? That's wiped out what we would have for our particular solution and the next thing of the particular solution. So what would you guess the particular solution would be? Second? AX? Okay, now this isn't a polynomial, that's exponential. Now normally we'd say e to the x, but we already got that. And if we didn't use that, we'd do x e to the x. We've already got that. So what would we try next? Let's try that anyway. Okay, and they do the A, I'm sorry. Is that what you were saying? Okay, I'm sorry, I couldn't hear you. Okay, my hearing's bad. Ax squared e to the x. Normally we've just done e to the x, but we already had that. Then we do x e to the x, but we already had that. So then we do this one. So then what do we do with this? Good answer anytime that you ask this in calculus or differential equation. What do we do next? Take a derivative. Sounds good. Okay. So y prime p or yp prime would then be product rule, isn't it? We love it, don't we? I'll do that part. 2a x e to the x, that's the derivative of the first times the second, plus I'll do that part, x squared e to the x. All right, done. But now we got to do y double prime particular, yp double prime. And what would that be? A little letter? Did you say 2a? That's right, 2a, good way to start. E to the x, is that what you said? Yeah, 2a e to the x. That's the first derivative of the first times the second. Plus 2ax e to the x. That's the first times the derivative of the second. Now go to this one. But guess what? If you're taking the derivative of that, that's the same as this, isn't it? So it's this thing over again. So that's plus 2ax e to the x plus ax squared e to the x. All right. Now guess what? Every one of those has an a in it. Every one of them has an e to the x in it. So let's factor that out just to see what happens. A e to the x times, and what's left? From the first term, 2 plus okay. Notice these two terms are the same, aren't they? So that'd be 4a to the x, ax e to the x. So that would be 4x, right? Follow it? factored out the AE to the x, add 2x plus 2x, that'd be 4x. Got it? Plus x squared, factoring out AE to the x. All right, now, and, okay. If we wanted to, we could have factored this too. I didn't want to at the time, but let's go on and do it now. Here, factor out an ax e to the x. And what we have left is 2, right? It won't write the 2. I don't know why it won't write the 2. This is such a pain in the neck. What is wrong with this thing? It was writing perfectly. It just seemed to have frozen. Okay. Okay, I don't know what it's doing now. It's never done a little black box around my options and draw a little circle running around a treadmill. Okay, sometimes this works. Control-Alt-Delete shakes it out of its syndrome. That's strange. It made everything go dim. Okay, let's see. Start Task Manager. Microsoft PowerPoint is not responding. Okay. That's such a pain in the neck because all it is a... Let's see what happens. What would you do? Wait for program to respond, restart, or close? What's that?
Is there anything you
What's
can't
it?
say?
Well, I mean, everything we had there, if I restart it, I'm afraid it'll lose it.
This is PowerPoint.
Yeah.
Oh, I didn't know the program you use to do PowerPoint.
Well, yeah, I'm using Screencast-O-Matic. That's still running, and it's recording all this, but the PowerPoint is what's frozen. Cast is still running. You see, that's this. We're recording all this still. Yeah, I mean, everything that we've had there. So you say close it. Okay. But all the writing that I've got there is probably going to die. But you got it. You can tell me where to start. Okay. Windows is checking for a solution to the problem. I count Windows as really reliable. I can't stand Windows products. I don't like Bill Gates. He's better now that he's retired, but okay. All right, never mind. So let's go and see if we can get PowerPoint started again. Now, this is a huge, very complicated PowerPoint file. I'll show it to you as soon as it comes up. It's that little program right up there. It's just a PowerPoint. And notice how long it takes to load it. It's a huge PowerPoint package. It's 3 pages. There's the first page, a graph page. There's the second page, a white page. Here's the third page, a white page says go back. That's it. And it's getting confused on that. Okay? This makes a lot of sense. Okay. It says this is available. Should I try it? Okay. I thought I tried it. Okay. Maybe I did. So let's go from current slide. It's all gone. Okay. All right. What's that? Okay, so let's pick up, let me get my pen back. Okay, our yp was ax squared e to the x. And we did our derivatives, and then, so I'll just write them down. Yp prime was ax e to the x times, and that's what we're working on. Can you tell me what the rest of that is? Second? 2 plus x? Okay, that sounds right. And yp double prime, this was the one we had written down, that was ae to the x out front. And what was left over? 2 plus 4x plus x squared. Is that what you said? Okay. Now, probably going to put those back together. In fact, I think I will put them back together. Didn't do any good to pull those out. Okay, our original thing was y double prime plus 2y prime plus, oh, that's minus 2y prime. You're letting me make mistakes here. Shame on you. Oops. More mistakes. Okay. Plus y is equal to e to the x, right? All right, so we're going to put the y double prime. I thought maybe it would help to pull it out. I don't think it will. So let's write it down. That's going to be 2, and you tell me if this is what we had before. 2a e to the x plus 4ax e to the x plus ax squared e to the x. That's my y double prime, right? Okay. Now, plus or minus 2y prime. Okay. So that's going to be minus 2, and the first thing here is a 2ax e to the x. So that's going to be 2 times 2 is 4. ax e to the x, right? Minus two, because that 2's there. Ax squared e to the x, ax squared e to the x. Okay, plus y. And plus y is plus a x squared e to the x, right? I'm going to add all those together. Those go to 0, those go to 0. Nice, huh? And we got 2a e to the x is equal to e to the x, because all this side was our was this stuff, and on the right hand side there. So guess what? 2a has to equal 1. Guess what a has to equal? 1/2. So our y particular is 1/2 x squared e to the x. So our y general solution, I'm remembering now, so correct me if I'm wrong, C1 e to the x plus C2 x e to the x plus 1/2 x squared e to the x. Now, you could leave it like that, or you could factor out the e to the x's and have it C1 plus C2x plus 1/2 x squared. Okay, either one of those are perfectly fine answers. Let's see what they wrote it as. Oh, I'm sorry. Their question was just find the particular solution, which is that. They didn't go back and rewrite the general solution. All they were asking for was particular. Okay, and we got it. Good for them. Suppose again that g of x consists of m terms of the kind given in 4.4.1. Flip back one page. There are those trial particular solutions. And let's say it consists of m terms of any of those, okay? That would be constants, linear, polynomial functions, quadratic polynomial functions, cubic polynomial functions. You can keep going as many as you want to. Any polynomial function. Sines and or cosines, and they usually occur in pairs. Well, in the your g of x could be either one of those. Okay, yeah, the g of x would be either one. Your particular solution would then be combinations of those. Okay, exponential functions, they just put 5x here. It could be any exponential function. E to the 5x, e to the x, e to the minus 2x, e to the minus x, e to the minus 3x, e to the 3, anything. Okay, any exponential function. But not just that, any polynomial function times an exponential function. Now they're just showing x squared, but it could be x e to the something x, to any power e to the something x. And then you could have any exponential function. They show e to the 3x, it could be anything, times sine of 4x, and that 4 could be anything too, positive anyway. 5x squared times sine 4x, or x e to the 3x sine 4x, or cosine 4x. In that table, you can mix and match lots of ways, okay? So, suppose again that g of x consists of m terms of the kind given in 4.1.1. And further suppose that the usual assumption for the particular solution is y sub p is the sum of all your particular solutions. Every one of those terms, where y sub p I would be 1 through m. Those are the trial particular solutions corresponding to those terms that we were talking about. Under the circumstances described in case 2, we can make up the following general rule. And here, well, all of you got books, right? Okay, here's what it is. If any y sub p contains terms that duplicate terms in the y sub c, then that y sub p must be multiplied by x to the n, where n is the smallest positive integer that eliminates all duplication. That's what we just did in this one. Our characteristic solution had both e to the x and x e to the x in it. Our particular solution was e to the x. So therefore our g of x was e to the x. That meant our particular solution had to be some form of, so constant a, x squared e to the x. If leave it alone like that. Okay. So let's look at example 8. These are so much fun, aren't they? Okay. So let's solve this one. Y double prime plus y equal 4x plus 10 sine x where y of pi, this is an initial value problem, is equal to 0, and y prime of pi, so I don't really like calling this an initial value problem. This is a specific value problem. It's not initial in that it's not 0, it's pi. pi, okay, but whatever, you can call it initial if you want to, is equal to 2. That's what we know. Those are our conditions. Where would you begin? Okay, and what would that be? M squared plus 1 equal 0. Yeah, we're going to use the homogeneous case. And what does that produce? Say again? Yep. You don't have the fingers to show it. Not quite. Okay. See, say again? What is square root of negative 1? I. Only this is going to be plus or minus I. Right? Also, when you square I, you get negative 1. When you square minus I, you get negative 1. And negative 1 plus 1 would be 0. That's the only two solutions you got. Now, we might have to go back a few pages and remind ourselves, what do the solutions for that look like? You may remember. But if you go back to 4.3, on page 133, they have case 1, distinct real roots. Yeah, we got that. Repeated roots. Yeah, we've done that. Case 3, conjugate complex roots. Okay? Now, there's a lot of blah, blah, blah there to begin with, but you turn on to page 134, and the bottom line here is that basically when you have your M being, when the M is, don't give the general case, A plus or minus IB times X, which is what we got here. A plus or minus IB. That's an alpha, it's not an A. I was going to say, why are they using some Greek and not some not Greek? This is alpha, not A. Okay? Alpha plus or minus I beta. Okay? If that was your M, in our case, there's no alpha, it's just plus or minus 1 beta. Okay? Okay? If that's the case, this is your M. Here's what your solution is. Y is equal to C1 e to the alpha x cosine beta x plus C2 e to the alpha x sine beta x. Okay? That's the general form when you have a complex conjugate solution. Okay? And your M turns out being complex. Now, what's our alpha? 0. What's our beta? No. Beta is the coefficient of your I. What is it? 1. Okay, very good. Okay. All right, is 1. Okay? So our solution, our complementary solution here is Y is equal to C1. Our alpha is 0, so that goes to 1. Cosine, what's our beta? Thought we just went through that. 1, okay, so x plus C2. What's our alpha? Huh? 0, so e to the 0 is 1 sine. And what's our beta? 1x. Okay, there's our complementary solution. Okay. Now, let's start working with the particular solution. I suggest to you we're going to have at least two. Would you agree? So let's do y particular 1. What would you suggest that to be? Don't give me a number. A x plus b. Very good. What would be your y particular 2? C. That means yes in Spanish. Okay. Say again? C. Ha ha ha. Why x? Because you can't use sine, you got a sine down here. But when you have sine or cosine here, you're going to need them both. So that'd be cx cosine x plus, remember we skip the d and go to e x sine x. Okay? Do you see why? Because when you take derivatives, you're going to wind up with cosines and or sines and stuff like that. So you need them both in there. And they like to skip the d's. Okay. So what are we going to do next? There's that leading question again. Take a derivative. Very good. Let's do y prime of p1, or yp1 prime. What would that be? What'd you say? There's your yp1. What's the yp1 prime? It's easy. Hey, you got it. That means yes in Canadian. Okay? All right. How about y particular 1 double prime? A is a constant. Derivative of a constant is 0. Okay. Didn't get much out of that, did we? Okay. How about y particular 2 prime? Minus cx sine x plus c cosine x. Got it. Good catch. That's the first part. Plus e. I'll buy that. Ex. Oh, that's all right. Nope. Cosine. You're taking derivative of the second part, right? Cosine x plus e, second, e sine x. You buy that. All right. Let's see if there are any like terms. Doesn't quite look like it, does it? And guess what we also got to do? A y double prime. This is getting fun, isn't it? What I'm going to do is get rid of a little bit of my extravagance here. Oh, I'll leave that alone. Okay. So our yp2 double prime is equal to, second, is it negative you said? Cx, no, not sine, cosine x. If you're doing the first derivative of the second, that would be cosine x minus c sine x. Very good. Okay, that's the first term. Second term, minus c sine x. That takes care of the second term. Minus, you said? Okay, minus e. Okay, no, that's, if that is correct to plus e, and you're taking the root of the first term, that would just be plus e cosine x. If that's what you said, that should be a plus. If you're doing the first times the derivative of the second, that would give you a minus, but then it would be an ex sine x. So which are you saying? Plus e cosine x or minus ex sine x? Okay, all right. Minus ex sine x. I'll buy that. Okay? I won't pay much for it, though. Okay. That's the first. You did the first of this. You did the first times derivative of the second. Now you got to do the... Waiting for somebody else here. What's the next term? Plus e cosine x, right? If you did the derivative of this one, I'm sorry, this one times the derivative of that, that gave you this, then do the derivative of this, e times that, exactly. Okay? We got one more term, and it'll only be one term, and what will that one term be? Plus e cosine x. Whew. Second? What's that? Okay, I can't hear.
So you could get 2e cosine x, because 2 of the same thing.
Okay. Where do you get? Oh, you mean these two?
Yeah.
Yes, okay, I got it. Yeah. So that winds up being 2e cosine x. Exactly. Very good. Good catch. Okay? Now, let's see if there's anything else. I don't think anything... Whoa, 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 whoa. Look at this. Minus 2c sine x. If we did it right, right? So we'll, shorten that a little bit. Our y, p2 double prime, is minus cx cosine x minus 2c sine x minus ex sine x plus 2 e cosine x. Got it? Shortened it quite a bit. From 6 terms to 4 terms. I like it. All right. Now we got our y double prime. Okay. Let's start with the top. Okay. What we have is 0. That's the y double prime. Plus plus ax plus b is equal to 4x. Right? That first one there. 0 is that part. This is the second part. So it'd be ax plus b is equal to 4x. Guess what b is? 0. Guess what a is? Coefficient is 4. For that to be true, a is equal to 4, b is equal to 0. So we really didn't need to be, but it was okay. We needed to check it out. Okay? Let's go to the second part. Your y double prime here is all this thing. So minus cx cosine x minus 2c sine x minus e x sine x plus 2e cosine x. Plus 2 e cosine x That's just y double prime. Plus y. Yuck. Okay, your y here, up here, is cx cosine x plus ex sine x. I write it that way because you see those two add to 0. So now what we have is minus 2c sine x plus 2e cosine x, and that's supposed to equal to 10 sine x. All right. Now, anyone want to make a guess what e is going to be? 0, because there is no cosine x on the right-hand side. And this tells us that negative 2c is equal to 10. So what would that make c to be? Negative 5. All right. Yeah. Okay, I think we have our two particular solutions. We're going to add them together to give our final particular solution. So y sub p is going to be, it's in here somewhere. There it is. A is equal to 4, so basically it's going to be 4x plus, because that was from here, b0, okay, plus, and our e was 0, and our c was negative 5, so it's going to be minus 5x cosine x from here, right? That's our particular solution, the sum of all our particular solutions. It goes back and combine that with our characteristic solution, and we have our final y, what do they call this, general solution, is c1 cosine x plus c2 sine x plus 4x minus 5x cosine x. There is our general solution. Oh wait, okay. Can I please erase some stuff? I'm running out of room. So let's erase this down here. I don't think we need any of this anymore. The only reason I'm erasing down here is because I need the space underneath that. I hope I've got everything I need. If I need any of that, y'all have to help me find it. Okay. But we know that y of pi is equal to 0. So let's say y of pi is equal to c1 cosine pi okay, plus c2 sine pi plus 4 pi minus 5 pi cosine pi. And that's supposed to equal 0. Right? Everywhere you see an x, you put in a pi. Okay, what does that leave us? What is cosine of pi? Help me, help me. No. What? Nope. Nope. Negative 1. All right. Multiple jets. Okay. So this will be minus C1. How about sine of pi? Zero. So forget that. Plus 4 pi minus, well, 5 pi. And what was cosine pi again? Negative 1, so that makes a plus 5 pi, and all this is equal to 0. So we got a minus C1 plus 9 pi is equal to 0. Guess what C1 must be? Must be 9 pi. Okay? Now, unfortunately, we got to figure out what y prime is, because that's our second initial condition anyway. So let's do y prime. There's your y. Y prime is equal to what? We know the C1 is 9 pi, so let's write it down. What's the derivative of cosine x? Negative sine x. Don't plug in yet, okay? Plus C2. We don't know what C2 is yet. And what's the derivative of sine x? Cosine x. Okay? Plus derivative of 4x. 4 minus 5. Oh, we got a chain rule, don't we? I mean, a product rule, don't we? So how are we going to take the derivative of that last term? You don't have to go by what I said. That last term. What's its derivative? You tell me. Say again? I can't hear. I see your mouth moving, but I can't make out what you say. Okay, it's a product rule, right? We've done the derivative of this one, and we plugged in what C1 was. We did the derivative of this one with the C2 in there. We did the derivative of this one, that's a 4, okay, that. And we're doing the derivative of this one. What's the derivative of that? Say again?
5x.
Okay, plus 5x sine x, right? Because the derivative of, okay, that's why I want to take my sign out of there. Plus 5x sine x, that's the first half. What's the second half? Minus 5 cosine x. Okay, that's your y prime. Now we know that y prime of pi is equal to, let's do it. Yeah. So minus 9 pi times the cosine, times the sine of pi. What's the sine of pi? 0. Forget that one. It's forgotten. Okay. And what would this be? Plus C2 times cosine pi. Second, minus C2. That's what I was trying to say, but I didn't want me to say. Plus 4. Help me. Okay. Yeah. Sine of pi is 0, so forget that term. It's forgotten. Say again? Plus 5. Got it. Okay, very nice. And we know that's equal to 2. Really? Okay. So this gives us that minus C2 plus 9 is equal to 2. Any guess what C2 would be? Say again? I can't hear you. 7. You got it. C2 is equal to 7. Now, please, we can put down our final answer. Okay? All right, if I erase all this. Okay. Since we have 2 initial conditions, we can eliminate those 2 variables. That's not what I wanted. Okay. I think that's what I wanted. Nope. There's what I want. All right. So our y is equal to, what was our C1? 9 pi cosine x plus, and what was our C2? 7 sine x, strange answer, plus 4x minus 5x cosine x. Done. Let's see how close they got. 9 pi cosine x plus 7 sine x plus 4x minus 5x cosine x. Look at that. They got it all right. Isn't that amazing? Okay. Whew. A bit of work, but it was all fun, wasn't it? Good deal. Let's erase all that ink, please. And let's look at example 9. Solve this. Y double prime minus 6y prime plus 9y is equal to 6x squared plus 2 minus 12 e to the 3x. Okay. I just remembered something I forgot. Okay. Where would you begin? Auxiliary equation of the homogeneous part. And what would that be? M squared minus 6m plus 9 equal 0. What would you do with that? What would you do with that? And what would you get? M minus 3, M minus 3. Absolutely. And what does that give you? M is equal to 3, but as a double solution, multiple solution. So what would that give you as your characteristics equation? C1 e to the 3x plus C2 x e to the 3x. All right, good enough there. Now let's move to the particular solutions. What would that be? Y particular 1 would be help me. AX squared plus BX, second, plus C. There's your first particular solution. Give me the second particular solution. Is what? E. Yeah, we don't use D's. Yes. I know it's time. It's sad, isn't it? Okay. What do you get? Just let's finish this up. E what? Okay, yeah. E what? Oh, you mean little e. Oh, okay. Okay. Little e 3x. What's wrong with that picture? We already have an e to the 3x in your characteristic solution. You can't duplicate that. Not going to work. So where would you go next? Multiply it by x. But guess what? You've already got that too. And where would you go next? Yes, then it becomes x squared. And I think that'll do it for us, won't it? Okay, you tell me what you do next. Okay, what do you do next, huh? Take a derivative of the first one, and then take a second derivative of the first one. Take a derivative of the second one, and take a second derivative of the second one, okay? And then you put together that second derivative minus 6 times the first derivative plus 9 times your thing we've got here with all those a's, b's, and c's in it, and set that equal to 6x squared plus 2. And eliminate some of the a's, b's, and c's, whatever they come out being. And then with the second one, you do the same thing. You've got your yp double prime, your yp2 single prime, and your yp right there. Of course, you have product rules all over the place there. So you put those together in that same left-hand side, and then you eliminate or evaluate what E is. Okay? So then once you got your A's, B's, and your C's, and your E's, then you combine that with the characteristic solution, and I think you're made in good shape. Now, I can't believe that they put e to the 3x and didn't find out it made it. Aha, yeah. That's when they went back and put ex squared e to the 3x. All right, and then you go on from there. Sorry, we've run out of time. How sad, how sad, how sad. But, unfortunately, I'm going to go on and... Are any questions before I end this?